that record stood for all of 21 months. Toward the end of December '04, one hit very close to Jakarta in Indonesia. Jakarta is the sixth largest metro area in the world. It's 24 million people. Population density, something like 130 persons per hectare, which is over 10 times the density of Kansas City. If this thing had made it all the way to the surface or even a low altitude airburst, it probably would have killed a couple of thousand people. Occurred during a terror alert. Okay? So imagine if we were at orange or red threat level according to the Department of Homeland Security and something like this happened. Fortunately, not only was it high enough up not to do much of anything on the ground and just south of the city, it also happened at 7:30 local time on a Sunday morning, which is a relatively unlikely time for the bad guys to be trying to blow a bunch of people up. But you start getting an idea of some of the geopolitical implications of these events if they were to happen in the wrong place at the wrong time. And also, they're not all airbursts. If you've been wanting to see one that actually hit us, a very palpable hit, made a crater, well, there you go. This happened in Peru, September '07, just about 2 years ago or a little bit more. The crater is 13 meters across and 3 meters deep. Ejector was thrown 250 meters. It did hit fairly close to some populated areas, a few small villages. Frightened some people pretty badly, and also apparently there was some arsenic content in the soil that somehow got released when this thing hit. So it actually made some people ill who fortunately recovered fairly quickly. Okay, so let's see. What's a recent near miss? This is great because JPL has this site at this URL here. You can go out and just see which ones have been zipping by really, really close to us over the last few days and weeks. And I think the closest pass this month has been one called 2009 TU. It flew by 4/5 of the distance to the moon in the evening of our time, Thursday, a couple of weeks ago. If that had hit, probably an airburst of about 300 kilotons. So a little bit like some of these other events, again, depending on where it was and how low the altitude was, it would have been pretty darn serious. And here is its orbital diagram. That's where it passed us. Notice, again, that's where the color of the orbit change is where it crosses the plane of the Earth's orbit, and that's just about where it intersects with the Earth's orbit. So it indeed came very close. That's us now, that's it now. This is supposed to be its orbit. Of course, it passed close enough that that probably changed a little bit. So, at least according to the JPL database, our next chance with it is the morning of Wednesday, October 14th, 2043, and then again in the late afternoon of Tuesday, March 10th, 2048. But they don't promise that they know exactly what the passage is made did to its orbit. So that's one that I think we're probably going to be keeping an eye on. Okay, at some point you've got to start wondering how much these things have affected human history. Mass extinctions are a pretty obvious effect. KT, dinosaurs gone. And sometimes it's not just a straightforward matter of an impact. Some of the latest thinking about the Chicxulub impact is that wasn't all it took to finish off the dinosaurs, but that where it hit was antipodal, which is to say exactly on the other side of the planet, from the Deccan Traps, which is a supervolcano that's down in India. And that let go afterwards, so it was this kind of 1-2 punch because the shock wave propagated through the Earth and started that stuff happening. The North American stuff I've already mentioned, but I want to read a quote here from Jared Diamond's book, Guns, Germs, and Steel. About 15,000 years ago, the American West looked much as Africa's Serengeti Plains do today, with herds of elephants and horses pursued by lions and cheetahs, and joined by members of such exotic species as camels and giant sloths. And all that stuff's gone. And if you happen to have native North American ancestry, you are descended from survivors of that event. As I mentioned earlier, the Clovis Comet is thought to have touched off the Younger Dryas cooling episode, and that may have affected people elsewhere in some pretty dramatic ways. There is a book called Survival of the Sickest by a professor named Sharon Moala, who suggests that diabetes became ingrained in the European genome because of the Younger Dryas glaciation event. Diabetes is in effect a cold weather adaptation. It increases body mass, concentrates sugar in the blood, makes it a natural antifreeze. The idea is that an inheritable trait would never reach the distribution level necessary to survive, being diluted out by competing genes if it didn't confer some survival benefit at some point. An example we're a lot more familiar with is sickle cell anemia that confers some population resistance to malaria. So diabetes may have come from that impact. Okay, now this is the really wild out there interdisciplinary part where I start talking about these things called black swans. Really fun book came out a few years ago by Nelson Nicholas Tallow, just called The Black Swan, the Impact of the Highly Improbable. Definition is large impact, hard to predict, rare event beyond the realm of normal expectation. The short version of that being just any low probability, high effect event, which certainly would include things like asteroids hitting the Earth. And what Taleb later explained in an essay that's posted online is that these kinds of events are in what he calls the fourth quadrant, where the payoffs are complex. It's not just a yes-no. It matters where an impact happens, when, how big it is. And if the probability structure is what he calls thick-tailed, which is a power law instead of Gaussian, it gets you up into here where ordinary statistics stop working and black swan events can happen. Now, this bleeds over into the general complexity of failure. Complex systems fail in complex ways. And a lot of what I'm driving at here is that the threat from asteroids is not as simple as it's sometimes portrayed, and oh, what if one big one hits us and takes out a city? There's a lot more to it than that. And some things that I've found useful in understanding how complex failure is, there's a really fun paper by a guy named Duncan Watts that you can look up. It's got a bunch of math in it, but don't sweat the math too much. Something he says in there is any increase, he says, finally, any increase in the network's connectivity has an ambiguous effect on the system's stability. On the one hand, cascades will become less frequent, but on the other hand, when they do occur, they will be larger. Hence, the system becomes not at once more robust, yet also more fragile, a feature thought to be endemic of complex engineered systems. And then the other one, which is much longer reading and really isn't very much fun at all in spots, but that I read anyway, is the Columbia accident report. And they explained in some detail that what destroyed the orbiter went a lot deeper than just a piece of foam that wasn't properly glued to a place like an external tank coming off and punching a hole in the wing. There were causes that extended clear back into the culture of NASA and the design decisions that were made 30 years earlier. And I would add that those, in turn, led back into the kinds of decisions that were being made in Congress in the 1970s, and those, in turn, of course, are some kind of byproduct of American societal priorities. So the roots of these things can go very, very deep. When a fourth quadrant type event happens, it reminds me of there's a quote from Hemingway where he asked some friend of his how he went broke, and the friend says, first gradually and then very suddenly. And we're going to look at my idea of a fourth quadrant events, and don't worry, I'm going to get back on asteroids here in just a second. But this is kind of a fun thing.